Welcome to Maths for All. I'm Aisling Flynn. This is Rational Numbers 1.2, Equivalent Fractions. Equivalent fractions. So this word means, if we break it up, it means equal, the same, and the valent part means value or how much. So together, equivalent means equal values. So we'll be looking at fractions that may look different but have equal values. So for example, here we see an illustration of 1/2 of a whole thing. And underneath you can see that a half is equal to many different types of fractions depending on how you divide the circle up. So 2 out of 4 pieces is equal to 1 out of 2. 3 out of 6 pieces is also a half. 4 out of 8, 5 out of 10, and 6 out of 12. Okay, so they all represent the same blue section of the circle, but they're describing different divisions. So bigger or smaller divisions and more or less of them. Here's another illustration. Let's take this yellow strip as one whole, so as 1. We divide it into 3 pieces, gives me 3/3. So each of those smaller rectangles is a third. We divide them again. Out of each third, we can make 2/6. Okay, so there are 2/6 made from every third. Okay, so we can say here on the right that 1/3 is the same as 2/6. Or 1/3 is equal to 2/6, or 1/3 is equivalent to 2/6. Likewise, if you take 2 of the rectangles that represent thirds, okay, 2/3, out of those you can make 4/6. So 2/3 is equal to 4/6, or 2/3 is equivalent to 4/6. Okay. So we saw this on the previous slide, that 1/3 is equal to 2/6. They're equivalent of equal value. So how are we going to do this numerically when we don't have a diagram in front of us? Well, let's look at numerators and denominators. Okay, so if we divide into 6ths instead of thirds, we'll be doubling the amount of slices if this were a cake or a pizza. Okay, so we're doubling the denominator. But to represent the same portion of the pizza, well, if you made smaller slices, you'd have twice as many. We'd also double the top number, so 1/3 gives you 2/6. Okay, so you have twice the amount of slices, but those slices will be smaller. Okay, so in future now, I want you to look at these yellow arrows. Whatever happens to the bottom number must also happen to the top number. So whatever happens to the denominator also happens to the numerator. This is to keep the proportion of the fraction the same. Okay, so here's another example. 1/3 is equal to how many ninths? Okay, so what we do is we examine the pair of numbers we have, in this case, under the line. So 3 is changing to 9. We're changing thirds to ninths. And for that to happen, it gets multiplied by 3. So 3 times 3 makes 9. To keep the fractions equivalent, you must repeat that action on the top with the numerator. And 1 times 3 is 3. So 1/3 is equal to 3/9. Another example, 2/5 is equal to how many 15ths? So look at the pair of numbers under the line, the two denominators. What's happening? Well, we're making fifths into 15ths. We've multiplied that number by 3. Okay, so we must repeat that for the numerators. Multiplied by 3, so 2 times 3 is 6. So 2/5 is the same as 6/15. Okay, now it can work backwards also, all right? We've got fifths changing to tenths. What happens there? Well, the 5 is doubled, or the 10 is halved, is what we're going to look at here, because we have to fill in the first fraction. To go from right to back to left, we're going to divide by 2. So I must repeat that action on the top line. 8 divided by 2 is 4. So it works forward and reverse. So 4 fifths is equivalent to 8 tenths. All right, what about 3 quarters? How many twelfths? So look at the denominator. 4 times 3 gives 12. Repeat that on top. 3 times 3 is 9. Okay, and here again we're going from right to left. 20 back to 5. Divide by 4 gives 5. 4 divided by 4 gives 1. So 1/5 is equivalent to 4/20. Okay, we can use this idea when you're asked to simplify a fraction. To simplify means to write something in its most basic form. So if you have a fraction like this, 8 over 24, there is a simpler representation of that portion. Okay, how do we do this? Well, we're going to find a common factor. So remember your factors, and to divide the top and the bottom numbers. Okay, using top and bottom as easier words for numerator and denominator. So I can see quickly, okay, I'm going to try 4. 4 goes into both numbers, and perhaps I'll have to repeat this. So 4 goes into both numbers. Divide 8 by 4 gives 2. 24 by 4 gives 6. But if I look at 2/6, I see there's still a common factor there. 2 is common to both of those, so I could repeat that again. Divide by 2 top to 1, and 2 underneath. 6 divided by 2 gives 3. Okay, and at this stage there's no more common factors, so we stop. So 8/24 is equivalent to 2/6 and also to 1/3, and 1/3 is the simplified version. Okay, improper fractions are next. So this diagram shows 8/6. So in the first circle, which is complete, there are 6/6 and 2 more, which makes 8/6. Okay, why is it called improper fraction? It's because the numerator, the number on top, is greater than the denominator, the number on the bottom. And this means that it's representing a number that is more than 1. Okay, so in this diagram we have more than one circle. It's called an improper fraction when the top is bigger than the bottom. Here's the same diagram. We can represent it another way, using what's called a mixed number. So we can say we have 1 whole circle and 2/6. So 1 and 2/6. Okay. So we can see from the previous slides that 8/6 is equal to 1 and 2/6. They show the same thing. So, but we can describe them different ways. So likewise, 7/4 or 7 quarters, we can represent that differently because it represents more than 1. So 1 whole circle would have 4 quarters. So that's 4. And then there would be 3 more from the 7. So 4 into 7 goes once fully, and there are 3 extra quarters in the second circle. 10/3 or 10/3. Well, how many full circles would you get? There would be 3/3 in each full circle, so we can make 3 plus 3 plus 3 is 9. So that's 3 full circles and 1 extra gives me 3 and 1/3. 13/5, you say to yourself, 5 into 13 goes twice fully with 3 left over, so 2 and 3/5. Okay, 5 into 13 goes twice fully, so that's 2 full circles with 3 more fifths. In reverse, if you want to go from mixed numbers back to improper fractions, well, I have 2 1/4. So 2 full circles will give me 4 plus 4, which is 8 quarters, plus the 1 here I have on the side, so in total 9 quarters. So here you do 2 times 4 is 8, plus 1 is 9. We're doing fifths here, so each full circle has 5 fifths. So 3 of those, 3 fives is 15, plus 1 gives me 16 over 5. 1 and 3 11ths, well, I would have 1 full circle, that's 11, plus the 3 here on the side, 11 plus 3 is 14 over 11. Okay. Now it's time for you to practice that. Check you've understood using the quiz and practice your written exercises. Thanks for listening. Here's your glossary.